There's so open, it's not necessarily for open source, but we've got an interesting open source story that I'll mention later on. But it's also because we want developers to focus on their idiomatic way of developing applications. So in the past, for example, Google App Engine, the old version of Google App Engine, there were some limitations. You couldn't do everything you wanted. But the new infrastructure that's been in place since, well, for a few years already now, since we introduced Java 8 on App Engine, actually, for the little detail. It's open in the sense that you write idiomatic code that runs on your machine, but you just deploy that on the Google Cloud infrastructure, and that it's the same programming model. All right. So let me give you also a little overview of what I call the spectrum, the serverless spectrum. So we have, let's say, on the left, it's stuff that is managed by your cloud provider. So it's not up to you to make security patches and such. And on the other end, you also have stuff that is managed by your team, your IT, your ops, etc. And we'll focus a big part of this presentation on the stuff on the top left. So App Engine Cloud Functions, which is a hosted functions as a service or platform as a service for the old acronym, where you deploy apps and functions. And on the other hand, you also have Kubernetes orchestrator to orchestrate your containers that can run on-prem on your own infrastructure. But it can also be like when you're more in the middle, where you have something like GKE, Google Kubernetes Engine, which runs your containers, orchestrates your containers, and the infrastructure is handled by Google Cloud. And we'll speak a little bit about the new initiatives around Knative, an interesting open source initiative around serverless on top of Kubernetes. And bottom left about not just functions and apps, but also the ability to run containers in a serverless fashion, so that you have the choice of the unit of work that you want to deploy, whether it's a function, whether it's an app, or whether it's your own container with anything you want inside. So the two serverless offering that we have currently, App Engine and Cloud Functions. So with App Engine, it's essentially application that you deploy, which react to request, incoming HTTP request, whereas Cloud Functions, it can actually reply to HTTP request as well, but it's very nice for event-driven workload. So whenever, so like the example I gave and that I'm going to show in the demo, where you have new pictures coming up on Google Cloud Storage, I want a function to be invoked, and we're adding progressively new events of that kind. The scaling characteristics can be a little bit different depending on how you want to tweak the concurrency level, how you want to, what else, the duration of the request, and so there are some different characteristics beside just the fact that it's an app or a function that you deploy. So what we recently launched in the recent month, so on App Engine, we have new runtimes, Node.js 8, Python 3.7, PHP 7.2, and Go 1.11. There's Java 8 that's been there for a while, and we're currently working on Java 11. There should be, not supposed to speak about the roadmap, but there's we're going to be having Java 11 pretty soon. It's vague. it's vague enough that nobody will fire me just for that. So especially those new runtimes and the fact that they are idiomatic, as I said, in the sense that stuff that runs on your machine should be running fine as well on Google App Engine. So any framework that you want to use can be used, any module, etc., can be used without any limitations. On Cloud Functions, it was announced as generally available last March for Node.js, and we announced a few months ago Python 3.7 and Node 8 in beta. And there's also going to be Node 10 very soon as well. Interestingly, so for App Engine, when you deploy your apps or services on App Engine on one region, although the URL is accessible obviously from everywhere, but you can also have functions which are dedicated to a particular region. So if you want to have some functions that are closer to your users, it's also a choice that you can make. What else? Environment variables, that's new. The new base image which underpins Cloud Functions. So it's an Ubuntu image, and there are tons of useful packages that are available. So for example, if you want to run video conversions, image manipulation, or if you want to run headless Chrome, so if you want to drive perhaps for your tests, for your end-to-end tests, for web scraping or that kind of stuff, you can run Chrome headless as a function. So this can be pretty useful. Also, we heard a lot of we got a lot of feedback from our customers around security aspects, security questions, and we added new capabilities that I'll dive in later on. Scaling controls, direct connection to our SQL databases. I'll speak about that. And the other thing we announced, that's serverless containers. So just like on the same infrastructure underpinning actually both App Engine and Cloud Functions, we are adding, so it's still in alpha, so it's still new, not released, but you can access that alpha. I'm going to give you a link if you want to try that, to let you deploy containers in a serverless fashion on the same infrastructure as App Engine and Cloud Functions. And I'll mention that at the end, so the open source initiatives that we have around providing building blocks for Kubernetes to create your own serverless platforms, and also the ability to run that on the Google Kubernetes Engine. So the new runtimes, so I mentioned, well, I will go very quickly through that. So there's the new Python 3.7 runtime, which is also, interestingly speaking, the same version of Python on Cloud Functions. So for those who are developing with Python, they have the same version on both App Engine and Cloud Function. And so just a few, like a week or two ago, no pun intended, we announced Go 1.11. The latest version. So now I'm going to focus more on Cloud Functions, and after that I'll show you my little demo. So with Go 1.11, what's nice is that so it's a very recent version of Go, obviously, and you can write again very idiomatic Go code. And what's even more interesting, that's the fact that it's vendor and module friendly, which wasn't the case in the past, or you had to go through some hoops to get that working. So now it's really more idiomatic to write your Go applications and vendor your dependencies and upload that. The link allows you to get access to the early access, I think, or alpha, I forget the exact label, if you want to try that. And yeah, so you just need to, when you deploy using the command line, if you don't use the UI, or you can just specify, the orange is not very visible, but it's runtime Go 1.11, and that's how you specify the version of Go you want to use. With Node 8, so actually the demo I'm going to show you in a few minutes, I was still using Node 6, so I haven't used yet async await, but the Node 8 runtime allows you to use async await. So for example, you see a bit of async, like here when I define the function I export, or here because I want to await the result of this call, get metadata. And this I should update to Node 8 because, well, I won't go into the details, but the app I'm going to show you later on isn't as real-time as it could be because I'm not using this approach. But that's a detail for me later on to update things to make a better version of my demo. Environment variables, so you can set environment variables that way, set envar. You can provide, use the Node approach for dealing with different environment variable sets with envars file, and there are additional flags like I want to update one or remove one variable or clear all environment variables. So this is useful. Scaling controls. When you've got lots of load on a particular function, so you can have 1, 10, 100, 1,000 instances of your functions running at the same time. But the problem is, say, you have one function that accesses a database. So you've got one connection to the database, but you know that there's like just one database, for example, and you cannot have more than, I don't know, 100 connections open at the same time. So what you can do is to say, okay, I'm totally fine with my functions to scale and create new instances, but I don't want to go past 100 instances, because that would mean I would have more than 100 connections to the database, and then that's gonna fail because I'll have issues with those connections. So you can say, okay, I'm fine with going up to 100 instances, but don't go behind. And otherwise, I mean, incoming requests will be queued till one function is available to deal with your event. So the security controls, there are two things that have been added there. So again, that was really the feedback from our customers, and we added those features for that. Because by default, especially, so there are two kinds of functions: background functions, which react to events, like I mentioned, cloud storage, to what else? Pub sub messages, etc. But you also have synchronous functions or HTTP functions, which you can call just via curl or a post request, get request, etc. And by default, those HTTP functions were public, so anybody could call your functions, which is problematic potentially. So now we're going to change things and make functions private by default, so that only you can call those functions. And so here's some examples how you can define some bindings to give particular roles to a function. So for the first one, I give to all users, I give the role of function invocation. So anybody will be able to call my function, whereas before it was on by default. So now I'm explicitly saying I want this function to be open. And the other one, on the other hand, specifies a special role to my other functions for function invocation. And here, all the functions actually had the same identity. So I was just adding roles, but they all had the same identities. But if I want to have a more granular way of giving roles, permissions, etc., I can say, okay, a particular function will have a particular identity. So again, some additional examples here. So I should certainly change the name of the functions or give a diagram, but in this slide and the next one, there are only slight changes, but I had two functions, and initially the first function was a publicly accessible function that was doing some, so my initial sample that I had was two functions, one which was taking markdown documents and transforming markdown into HTML, and the second function was a function which was taking HTML and storing that on in a database. And I wanted the first one to be accessible, and the second one, and the first one to be able to call the second one, so that it gives the HTML to the second one, and then the second one, the sole thing the second function was allowed to do was store the data in a database and not call the functions or do anything else. So that's what I did. The first function, I allow it to call other functions. That's the role cloud functions invoker rule. But for the other one, I give another identity to this second function. And one of the things that you see changing here is that this one will only be allowed to access a Cloud SQL database. On Cloud SQL, there's MySQL and PostgreSQL for reference. So that's what I did. 2 functions with special roles and special identities, so as to be sure that even if someone somehow were able to access the code and update the code of my function, I mean, the person wouldn't be able to do anything else than calling the second function for if they access the first function, or in the case of the second function, well, they would be able to actually access the database, which is probably a bit more dangerous. But at least things are more secured in a smaller perimeter. Well, right, so it's time to show you some of the cool stuff that I like about App Engine and Cloud Functions for my microservices. So I created a little application which is about sharing pictures. So for example, I'm gonna take a picture of this audience up like this. I'm choosing the camera, and okay, you can smile. Let's see. So let me show you the actual app. So you can even try the app yourself and take pictures if you want. So piccadilly.appspot.com. So what is it? So there's if you look at the application, so it's a page for sharing pictures. You can see the pictures that have been taken. You can see the labels. The labels are actually stuff that's in the pictures. I'm using machine learning to discover what's in the picture. So there's it's a bit dark, but there's when you click on the camera button, you can take pictures. And there's a page where you can see the list of most frequent labels that are found in the pictures. I'm updating that most frequent list on a regular basis, regular intervals. But I also have a dedicated front end for administration, because I'm also doing some filtering, because I don't want, since it's anonymous, I don't want anybody to put anything on my picture sharing website. So again, I'm using the machine learning API, the Vision API, to discover that there's some racy or violence content, etc. So let me show you that. No, before I show you, or I'm going to show the app first, and then I'm going to explain the what it looks like under the hood. So this is the picture I've taken. And Stefan didn't see that I took a picture of him a few minutes ago. And yeah, whatever. So this is me trying yesterday at night to see if everything was working fine. So what do you see here? There's some background color around the pictures. That's actually thanks to the machine learning API that I'm using, that adds the most frequent color, or most, let's say, the dominant color of the picture. So you can see some different colors depending on the picture. You can see the label. So I can, let's say, I want to, so if I click on that, I should see only gadgets or electronic devices. Okay, seems to be the case. What else? Technology, or, well, never mind. Or here, I can see the list of most frequent tags. Let's say one that would be interesting, a chair, if there are chairs. Okay, there's a chair, another chair, some more chairs, etc. What else? I think that's, oh yeah, that's a bit of Inception style. You know, you take pictures of pictures of pictures. That's kind of cool. And so, as I said, I have an admin interface where I can see the pictures that have been filtered. So for example, this one has been filtered. I can show it because I noticed that it's okay. But there was one which was interesting a while ago that was like this one. The Vision API thought probably that it was about blood. So there's some violence, but it was actually some cherries, strawberries, and such. So that wasn't blood at all. But I also took, as you can see at the bottom of the screen, but I'm not going to zoom on these ones, I took pictures of magazines with ladies, and it noticed that it's probably adult or racy content. So I'm not going to show that, but I just wanted to show that those images were filtered. So yeah, that's about it for what the demo looks like, and then I'm going to tell you about how it's been implemented. So I upload my pictures to my first service, which is my front-end app engine service, which is developed in Java 8. There are two aspects, so I could have probably done two services for that, but so there's what's serving my front-end. I have a Vue.js JavaScript front-end that calls my underlying API. So this is Java plus Vue.js. So there's a part which is the URL routing as well as the API that's used by my Vue.js code. Whenever a picture is uploaded, I'm gonna put that on Google Cloud Storage. Yeah, I forget. And so the raw bytes of the pictures that's stored, the binary picture is stored on cloud storage, but I also store some additional metadata in Cloud Data Store. That's our document-oriented serverless data store. Putting some metadata there, like the path where I can find that picture, and I'm going to store the details, like the labels that are found later on. So when this picture is stored on cloud storage, there's an event which is triggered, and the event is going to call a function, and the function in turn will call the Vision API, which provides some machine learning tricks to discover the labels. That's the tags I have under my pictures. It will discover the dominant color, and it will also provide you with filtering to see if there's some violent content, etc. Once the Vision gives me some results, I update the metadata in Cloud Data Store. And also at regular intervals, what I'm doing is, so the little icon on the right, it's Cloud Scheduler. Cloud Scheduler is a new product for doing basically a cron in the cloud, so at a regular interval of time. It's triggering an event, which is via PubSub. I'm using PubSub for that. This event is going to call my function to compute the most popular tags for the most popular tags for my pictures, and it's updated on a regular basis, because otherwise as I have to go through all the pictures, it's a bit expensive in terms of queries to the data store. So I decided, okay, I'm going to do that once in a while and just update and store the results of the most frequent tags again as well in the data store. So I have two kind of entities in my data store: the metadata for pictures and the most frequent tags. And last but not least, there's my little admin app, my admin service, which is actually a Go application on App Engine. So I have two services and two functions for the admin, the front end, the Vision API, and the function to calculate the most frequent tags. So now I'm going to show you a bit of code to see what it looks like at last. So it's there. I think I'm going to increase the font size a little bit. It should be readable. Okay, so I have my four services: my front end, the Go app for the admin, popular, that's for the most frequent tags, and the Vision API. I'm going to start with, let's say, the front end. So it's sources, main. So there's some GUI, but I actually did it in Java. So here's my app. I was using a small framework, so I'm probably, I decided to go with the Spark Java framework. I never played with it, so I wanted to have fun with that. And I like the fact that there's a nice little DSL for defining the routes. So this is the route of my app. Here I can see the list of tags, a particular tag, and then there's the API part where my Vue.js frontend is going to call this API part. So for example, here, this is the post request where when you use the app, it's going to store the picture in Google Cloud Storage and the metadata in Cloud Data Store. So that's what I'm doing here. I'm creating metadata here for my app, so whether it's been filtered, the labels, the path, etc. And here, so I'm gonna increase that a little bit. And here I'm then uploading my picture on storage, on cloud storage here. So bucket, and I'm going to create my picture and upload it to Google Cloud Storage. What else? This one for fetching and calculating the most frequent tags, etc. And I'm not going to go deeper, but I want to show you the Cloud Console afterwards. And this is my Go app for the admin interface. So it's a little simpler, just 3 routes that I have here, and it's doing pretty much the same kind of stuff. So where's the code? So there are some queries to find the filtered and non-filtered pictures from the metadata in data store. I'm running some data store transactions for that, and here I'm able to delete pictures, etc. So again, yeah, I'm doing things like data store delete, etc. A bit more code for, let's start with the vision service. So this one is using Node.js. So I don't necessarily, so for Node.js, that when I started developing that, there was only Node available, so I used Node, and I'm more familiar for the backend and the app engine, so I'm more familiar with Java, so I used Java. And one of my colleagues developed the Go admin front end, but you don't necessarily have to use different languages, but at least I wanted to show that in the demo. Your microservices can be in any language or runtime, and they just cooperate totally fine together, obviously. For the Vision API, what's happening is that there's an event from Cloud Storage that's coming up that is telling me, okay, there's a new file from a bucket, and with that file, those details, I'm actually make a request to the Vision API, asking for label detection to find what's in pictures, image properties that's for finding the dominant color, and safe search that's for doing the filtering, adult, racy, violence, etc. Then I'm calling the Vision API with my request, and when it comes back, I'm navigating through the JSON payload here, and I'm finding dominant color, safe search, etc. And I'm doing the filtering here. So so I think the causes are elsewhere. Safe search. Where did I store that? I don't find the. Well, never mind. It's that's where I'm checking that something is violent, adult, etc. So anything that is likely, very likely, violent, etc., I'm going to filter that so that it's not displayed. Once I'm happy with the result of the Vision API, I'm going to store the new metadata, update the metadata in my data store. And for the last service that I have, server.js. So here I'm actually using one of the new features, like the environment variables, because by default I'm using this front end for the API to fetch the most frequent tags. But if I'm in development mode, I can point to a different URL and specify somewhere else for my API endpoint that this function, this service is using. And so this is where I'm actually calling the complex and expensive operation that lists all the tags and their frequencies. And then I'm updating my calculation in the metadata in the data store. Okay, so that's pretty much it for the code, and I just wanted to show you what I like. So here in the front end, no, in the console. So here that's the app engine. So yeah, 12 minutes. So here that's the app engine front end console. So I can see the list of services, like the admin services, the main endpoint. What's interesting is that you can also have different versions for your services. So the main one, that's the one you saw, but I also have a gray one. So it adds a gray background to the website. Although it's not so it's serving, but it's not being served for my users. But I can do things like traffic splitting and say, okay, I want to split the traffic. Let's say you want to do some canary deployments or that kind of stuff. So you can say, okay, I have a gray one, so I'm going to add gray. I want to provide, let's say, something significant, like 20% of the traffic to the gray version. And now 20% of the users are going to see, where is it? Here, the gray background or not. So white, at some point you should be seeing some gray. You should be seeing some gray. Of course, it's not showing gray when I need that. I should perhaps increase the... Oh, interesting. So what do I do? Gray, traffic split saved successfully, so it should be applied. It usually doesn't take that much time for showing gray. Come on! Demo failure, okay. That's weird. Ah, some gray. So the thing is that when I get the little toast message, so the settings were saved, but it doesn't mean that the split is actually already active. So it can take a little while, but usually it's a few seconds, or let's say 20 or 30 seconds, but not more. So I'm getting some gray, some white, some gray, some white. So that's useful. What else do I have? There's monitoring things, etc., which are pretty cool. What I wanted to show you besides that, so I have some interesting things on Cloud Functions as well, but I want to show you something that I find is cool. Yeah. So for first, things like the logs. For example, I can just look at a particular the logs of my functions or of a particular, let's say the Vision API. I just want to look at the logs for that particular microservice, or I can also look at the logs of one. So show matching entries. Oops, show matching. Hey, wait, what is doing that? Okay, the tooltip is weird. I can also show the logs just for one particular execution, which can be pretty handy to figure out what happened for a particular request that came in error. So, and also if there are errors which are not caught, I can use Stackdriver. That's the product I'm using. Not Profiler. That's error. I wanted to use, or I can search that more rapidly here. Error reporting. So if there were some uncaught errors, but there haven't been in a while. Oh no, so there was one. That's weird. Dominant color, perhaps a failure in the call of the Vision API somehow. So it happens once in a while. So I can check that errors are happening and being handled. And another cool thing I wanted to show you, because when you have microservices, you want them to be tooled, monitored, etc. That's the debugger, Stackdriver debugger. So this is Java perfect. That's what I want to see. So for example, whenever let's say someone calls, so this is for posting a picture. Yeah, why not? You can add debug statements in a way on live production code. For example, here I want to print the picture ID here, picture ID. So this is the syntax you have to use. And it's going to add a log in Stackdriver logging automatically whenever this particular point is accessed through the execution of the incoming request. So for example, here, so I don't know what's the gap. That's some cool pictures. If I go back to the logs, so it's in the main module, yes, in the main module, and I should be seeing load new logs. So what was my picture? I think I said picture ID. So let's see if I can find the statement. Did I say picture or picture ID? Forget. Searching new picture. Load neural logs. So or jump to now which would be jump to, no, not jump to time. I just want to see the very latest ones. I'm not seeing my statement there. Oh no, that's because I'm still on Cloud Functions, I'm sorry. Up, so you should be seeing load last hour, but never mind, so that I have the very latest info. And drum roll. I did that yesterday, it was working. I'm not seeing it. So there should be a log somewhere. Let me try again. So I'm going there, and or did I put the log statement in the right place or not? Oh, yeah, might be hidden somewhere. Where is it? Yeah. So the log point is there. That's hidden in the log details in this particular request. So here, log point, picture ID. Identify a picture ID not found. That's not what I expected. But so if I had properly written my log statement, it should be showing the. Well, I want to try to figure out why it's not showing the ID, but it should be there. Perhaps I did a typo or something, I don't know. So it's nice because you're able to add logging directly within live production code, which is, I think, pretty cool. Right. So I only have 5 minutes to go quickly through the end. So that was my app with 2 services, 2 functions. So what else? We have 2 services, new services that were actually part of App Engine standard before, but that are now available for all the payloads, whether using VMs, Kubernetes, etc., or any of the compute options available on Google Cloud Platform. So you're able to create tasks which are, let's say, batch jobs that you want to run once and only once, and things like that. So you can delay execution for your background needs. So this is new. That's been put outside of App Engine, so that it's reusable elsewhere. And I didn't show you this part, but the function that was doing the frequent tag, frequent label calculation, it was triggered on a regular basis thanks to Cloud Scheduler, which is basically a big cron service which is available. And you can call PubSub, so it sends events via PubSub. That's what I did in my demo. Or you can call other URLs. And very quickly, serverless containers. So at Google, we're pretty used to launching containers. We're launching 4 billion containers per week. That's pretty nice number. But just like you'd deploy functions on Cloud Functions, you're now able to deploy your own container. So it's see that more as a way of a packaging of your function or app or etc. or service, your service in general, but in the form of a container that you run in the very same serverless fashion on Cloud Functions. So you put anything in a Docker container, any language or runtime that you want to use. There's also a link if you want to try that for yourself. And compared to functions, so the sole difference when you deploy a function and when you deploy a container, it's really just that you add an additional parameter to say, I want to deploy a particular image. Here I'm using the Google Cloud Registry, but you could use a Docker Hub, I believe. I haven't tried. The other thing that we announced recently, that's Knative. So that's an open source initiative to add serverless building blocks on top of Kubernetes, so as not just to reduce the number of YAML files and YAML lines that you are writing, but to simplify the process of providing a serverless infrastructure. So if you're ops, for example, you could wish to tailor Kubernetes for your needs so that the end users, your developers in-house, can deploy their own functions and apps and containers directly on the in-house on-prem Kubernetes cluster. So there are 3 components: build for building the artifacts that are being deployed, serving for serving well, as the name implies, for serving the payloads, and events to react to events, your own events, or a CNCF initiative called Cloud Events. And we worked on that with perhaps one less partner than in this picture. And funnily, both IBM and Red Hat are on the same line. So I didn't do it on purpose, and I didn't touch that slide after the news. So we worked on that initiative with other providers. And for example, folks like Pivotal, they have a framework called Reef for functions, and they actually retrofitted the whole framework on top of the Knative building blocks. And others, SAP also did something like this, and IBM is looking into that as well for OpenWhisk. I don't know if it's done or they are working on that already, or if it's done already or not, but it's now going to be the base for, let's say, the best serverless and standardized way of creating serverless deployments on Kubernetes clusters. So it's not necessarily developer-facing product, so it's more perhaps for your ops to set that up, or for cloud providers to provide that in terms of infrastructure for your users. So it's really primitives in the sense that's building blocks, so it's not a finished product. And it's not necessarily the right solution for everyone in the sense that it's not for all the developers, but perhaps more for the DevOps people who provide such infrastructure for your developers. And so we also run Kubernetes on the Google Cloud Platform with a GKE, Google Kubernetes Engine. And we're adding as well an add-on to GKE so that you can run Kubernetes payloads on GKE. And instead of, so you can just specify the cursor where you want to upload that. And it also works well, for any Kubernetes cluster. And that's about it. And I'm actually over time. So I guess we don't have time for questions, if I'm correct. So I'll be on the Google Cloud booth over there. If you have questions, I'll be happy to answer you. So thanks a lot for your attention.